All right, so for our semester research project, we went ahead and looked into how hydrogen fuel cells can be used to transport and store energy, as well as make modern renewable energy more stable. So in this presentation, we're going to cover what hydrogen fuel cells actually are, background of the problem, our theory and analysis of the solution, a quick summary of our research, and we're going to wrap it all up. So hydrogen fuel cells are a way of using hydrogen and oxygen to create electricity. And there's positives and negative aspects of hydrogen fuel cells, just like there would be anything else. The pros are there are zero emissions because you're not burning anything. Hydrogen has a high energy density, and the fuel cells themselves don't need to be recharged. They just need to be supplied with hydrogen and oxygen, and they can be adapted for multiple uses. Some of the cons are fuel cells can be expensive to produce, and hydrogen itself is expensive to produce with cleaner methods. Distribution of fuel cells would require additional infrastructure that we don't already have, and hydrogen requires large amounts of energy to produce. So the problem statement is when hydrogen is produced from non-renewable resources, it's not sustainable. Other renewable sources, such as wind and solar, have shortcomings, though, that can lead to inefficiencies and lost power. So these are some of the problems that we're going to try and solve.
So our solution to this problem was to use hydrogen as a supplement for existing renewable energy resources so that it stabilizes them and uses it as a buffer for these sources for easier transportation and easier storage of energy. Some of the problems that exist with the current way we use hydrogen is that most hydrogen produced in the US is produced using natural gas, which makes it called dirty hydrogen. Most renewable sources have inefficiencies as well, so we want to combat that. So a couple previous solutions include using hydrogen as a replacement in combustible engines and using more renewable sources to make up for lost power. Our proposed solution is to use renewable energy resources in combination with hydrogen to make green hydrogen and improve the inefficiencies that some of the renewable energy resources have and easily transport hydrogen where it's needed. We also want to consider applications where hydrogen gas can be used to replace gasoline, and we'll talk a little bit more about that application later in the presentation. So here's the scope and breakdown of our solution. It starts with the energy production industry and spans into fuel source for consumer vehicles, energy and heat source for remote locations, ecologically friendly applications, and fuel for vehicles used in shipping.
So for the analysis of our solution, of course, it still has some pros and cons, just like everything else. Some of the pros would be that hydrogen can be used to store energy long term. You don't have to worry about electricity leaking out of batteries, or you don't have to worry about the hydrogen breaking down, so it can be stable for a long time. Existing infrastructure can also be converted over to hydrogen. So in some cases, you don't need to start from ground zero. You can convert what's already there. Extra hydrogen that is produced can be used in manufacturing processes to produce like other products that would already be using hydrogen. Hydrogen can also be used in microgrids to provide power in like remote locations or villages, and this was actually implemented in Bangladesh a few years ago. Some of the cons to our solution, hydrogen production does require a large amount of electricity, and while we are proposing that that energy source comes from renewable sources, it still does require quite a bit of power. And then also hydrogen systems do have high upfront costs as well to actually get them up and running. As part of our analysis, we wanted to compare different types of vehicles and different vehicle technologies. We'll see the table on the next slide here. Hydrogen cars currently in the US are only like sold and operated in California. So all of our prices are based off California prices to reflect that. And we needed a way to compare the different types of vehicles. So we looked at the cost per mile to actually compare how expensive it would be to drive one of these. One example here, the cheapest to drive, so dollar per mile, is the Toyota BZ4X. It is a fully electric vehicle, so not hydrogen fuel cell. However, it has drawbacks just like other fully electric vehicles, where the max range is almost half of the other vehicle types, and it also requires time to charge. So you can't just pull up to the fuel pump and fill it up in a minute or so. All right, and this is the table. So we compared 2 different hydrogen vehicles, a fully electric vehicle, and then a gas hybrid. That's pretty common. You can see on the column far to the right there, we have the cost per mile. And the hydrogen vehicles are similar to the gas hybrid. So it's not that much more expensive to drive a hydrogen fuel cell vehicle. The cheapest, of course, being the fully electric Toyota. But as you can see here, it has a max range of 252. And the hydrogen and the gas hybrid are 400 to 500.
Now, some of our project alternatives to the electrolysis would be the use of fermentation to produce the hydrogen. Now, with this fermentation, there are methods such as the dark fermentation and integrated fermentative production, where it uses the chemical conversion of biomass to hydrogen, with biomass conversion in the biorefineries to create the hydrogen that would be used. Another method would be just using the hydrogen-rich gases instead of pure hydrogen, which is created from electrolysis. And then this would be able to be used in existing infrastructures, such as the combustion engines, because they can use less than pure hydrogen mixtures. And this less than rich gas can come from steel mills and the other refineries as a byproduct. And then in summary, we can see that fossil fuels in general just aren't going to be able to be maintained in the long term as the main power. And that we can also see that renewable is unreliable and expensive, along with hydrogen. But hydrogen can be used in a multitude of different ways, such as transportation or industry to create energy. And then the current infrastructure right now can be used with hydrogen production, such as the combustion engines being supplemented with hydrogen, or also the turbines that use less than pure hydrogen gas. And then one of the best things about hydrogen is that there are no harmful emissions when used correctly, because of it using hydrogen and oxygen creating water, which has no harmful side effects. And thank you for taking the time to watch this. If you have any questions, please feel free to reach out to us. And then here we have 2 slides of our sources